this edition of Coatings Decoded. I'm Vaughn O'Day with Tnemec Company, and today I'm joined by Mike Caputi of Epoxytec, a specialty manufacturer of linings and materials. Welcome, Mike.
Thanks for having me.
And I should add that Epoxytec was recently acquired by Tnemec, and we're excited to have Epoxytec in our line and want to hear more about it.
We're excited to join forces. I'm excited to tell you guys all about it.
So, Mike, why don't you just briefly tell us about some of the materials, the specialty linings that you guys offer and the uniqueness of these materials?
Yeah, what's unique with the Epoxytec lineup, we think we fill a gap that Tnemec has had, and that is with what we call structural epoxies. These are ultra-high build, high mechanical strength liners that really belong in a special condition. And those conditions are typically underground conditions where they could wreak havoc with more traditional coatings.
Yeah, so below grade concrete structures usually are plagued with water infiltration, and other forces that plague these non-structural materials. Can you describe some of the tacit advantages of the structurals?
Yeah, if you take a look at coatings historically, coatings have always been pretty much designed with the main focus of what we call, resistance to direct attack, right? These are formulated from the perspective of, what corrosive do we have to deal with? And you take a look at historically, we were looking at situations in water and wastewater, which is primarily H2S attack and sulfuric byproduct of that. What Epoxytec does is we took a look at other conditions that might come up, and we developed coatings to take care of not only H2S, but also looking at things from an I&I perspective.
Right, that infiltration and inflow. And that is a problem that is plaguing our collection systems, right? That's
correct. Many asset owners and municipalities across the country are realizing that a lot of water infiltration is coming in through their underground collection systems. This could be from the manhole, from large diameter pipe, from their lift stations. And that's causing unnecessary water coming into the system where they're forced to look at expanding. So they took a real close look at that and realized, we need to seal these leaks to begin with, because clean water shouldn't be entering the system, because at the end of the day, it's all being treated the same way.
That's right. So these non-structural linings, these chemically resistant, sewer gas related resistant materials, are they really stopping I&I?
Yes and no. When you take a look at the design criteria that you need for I&I resistance, it goes beyond just H2S. It goes beyond just direct attack, which are what non-structural and more traditional coatings have always been performing to resist. Whereas you take a look at the CIPP world and you take a look at other liners that are dealing with I&I, they're providing a benefit because of their high mechanical strength to resist forces that are accumulating behind the film. And coating companies, especially ones that are just formulating with the perspective of what can we do for direct attack, are falling short because they're having delamination issues, or they're having blistering issues. They're having failures, quite frankly, because they didn't take the criteria that we need to resist forces that can build behind the film as well. Because when you're dealing with I&I, these are what we call negative side pressure coming from behind the film.
Right. So if I understand it, it's the high mechanical strengths, these salient properties of these structural epoxies and their ultra high build capabilities. They're able to withstand those forces much better than the traditional non-structural epoxies. Is that right?
Right. And, take a step back, we should also define more what a structural epoxy is. And every manufacturer might have a different definition for this, but ultimately, what we're doing for I&I is a structural coating from our perspective is something that is high build enough with enough mechanical strength to deal with these forces, even should there be accidental unbonded areas, so that those forces don't penetrate and influence the backside of the film enough to create a failure to have a problem. So when you take a look at something like an ultra high build, high mechanical strength liner, and this could be something like a polyurea, an epoxy, even a composite, the whole idea here is, should there be an unbonded area, can that film hold back I&I? we took the approach to use epoxy because we like epoxies in underground environments due to their proven track record in high moisture environments, their surface forgiveness, which are other considerations you have to think about when you're going in underground collection systems.
Sure, absolutely. Are these structural epoxies new technologies to the marketplace, or are they proven and they're existing out there?
I think they're increasingly becoming more popular. So some might think they're new, but they've been around for a few decades now, and they've been proven. They prove themselves out the best, obviously, in the conditions we're talking about, which are typically below grade conditions where you're dealing with a variety of different forces where thinner films are just struggling to keep up with due to their lack of high mechanical strength and just brute thickness.
Sure.
So they have been proven. There's two different worlds. You look at a treatment plant, above ground world, and they have a place there if you're dealing with things that are buried assets or below grade, or you have infiltration coming from the bottom of tanks.
Right.
But really where they shine the best is in a collection system world, in my opinion.
Sure, absolutely. So how are these materials applied?
There's a variety of ways to apply these materials. For our material specifically, we have 4 different products, one of which is trowel applied. That lends itself very well to areas where you can't access equipment or you can't bring in heavy machinery, and someone can, a small crew can go and line manholes direct to concrete using our product as a resurfacer and a liner all in one shot with a high build structural grade epoxy. And then we have a spray version that's usually sprayed out via heated plural component equipment because, again, these are very thick products, so they start off highly viscous, and you need heat to drop down to viscosity so you can get them to pump and spray onto a wall. At that point, you can build these things anywhere between 125 mils to almost 500 mils. In our case, we can go about 3/8 of an inch without sagging. And that's where you get the brute strength. That's where you get the mechanical strength. That's all contributing to holding the liner in place, especially in cylindrical environments where you have forces that could be trying to penetrate through the film. We take shape, and we also have the high mechanical strength to resist those forces.
Right. So you got that hoop strength.
You do.
Capability of that. So you not only have a trowel applied version for those smaller confined areas where, the applicators just want to trowel up, but you also have the heated plural component versions. It sounds like we have 3 versions of the structural grade epoxy for that. What is the ratio for these materials, and are there advantages of that mix ratio for that plural component equipment?
Well, the advantage Epoxytec specifically has is, we run a certified contractor program where we bring in contractors to get trained on a material and qualify them for bidding. One of the things we let the contractors know is you make one investment in one plural component rig. Ours just happens to be set up 1-to-1 by volume. You get access to all 3 of our products. So we have a product that's designed particularly well for manholes that we call our CPP spray liner MH. Then we have another product that's a sister product to that that's geared more towards wastewater treatment plant, larger wall design. And then we have a drinking water version of that as well for NSF 61. And one rig, they get to plug and play all 3 products, all configured the same way, all one investment. And it's a benefit for the Epoxytec portfolio to be offering the contractor one investment, but they get access to really anything that they're dealing with, either collection system, plant structure, or drinking water wise.
Sure, and they're all 1-to-1 by volume.
1-to-1 by volume.
That's great. That's very convenient for the contractors, and may offer some advantages there on the stoichiometry and the like. So, not only do we have materials now, these structural epoxies for the wastewater and that I&I abatement, but we also have that spray liner 61 for the drinking water.
Correct.
Where you might also have some infiltration through the concrete, high moisture vapor emissions, that are plaguing these non-structural, more of the traditional materials, right?
Correct. It's a good tool in the toolbox for contractors and for the municipalities and engineers that are taking a look at it as well. There's sometimes logistical challenges out there to get traditional multi-coat systems on there, where this could be a logistical advantage to just go direct to concrete. So oftentimes when an owner knows of these kind of products and they see the benefits that are happening underground intercollection systems, oftentimes they see also benefits at the water treatment plant or the wastewater treatment plant side of it as well.
Sure. Now, you mentioned the thicknesses several times and ultra high build capabilities. What thicknesses are we typically seeing in terms of minimums and maybe even maximums with these materials, directed concrete?
You typically see a minimum dry film thickness starting at about 125 mils. It's not uncommon to see them go up to 250 mils as well when you have deeper assets with higher pressures. And then you can also see them go well into 500 mils, which is a half inch. Typically, we do that on large diameter pipe lining because we're also dealing with internal pressures of the pipe.
Wow, that's really thick. And you mentioned these are ultra high build. That is certainly well beyond the capabilities of these more traditional epoxy liners.
Right. So you can imagine when that cross-links and cures with the high mechanical strength you get out of it, then you can almost visualize why it resists I&I so well and all those forces that can build behind the film.
Absolutely. Are there other advantages of the structural epoxies? Maybe some of the other mechanicals or physical traits that they may possess?
Yeah, there's a decent amount of advantages when you start really thinking about an ultra high build curing out and developing rock solid. If you can imagine, these start off as paste grades and then they get liquefied through the heated plural component. So that gives the ability to spray high build. You'd be able to go on, let's say surfaces that are typically difficult to spray traditional coatings onto because it bridges so well all the imperfections of the surface. If you have micro cracks, if you have surface imperfections, this offers a covering really that can almost be viewed as a resurfacer and a liner only in one shot for certain conditions.
Wow.
I don't recommend that every time, but there's some situations where the logistical benefit really helps, especially if you want to reduce bypass pumping or if you want to reduce any kind of logistical headache that might be coming into the situation if you're specifying a traditional coating system that has multiple coats.
Right. And how about the return to service times with the structural epoxies? Are there benefits there as well?
We've been spraying as far down south in South Florida all the way up into Canada and with all different temperature ranges. And there's typically not a situation that you wouldn't have a 24-hour return to service. Sometimes quicker. And you can also force heat this with indirect heat, especially in situations where you want to have a quick return to service.
Wow, that's a huge advantage over some of these more traditional epoxy linings. Wow, Mike, there is a lot to unpack here with these structural epoxies. We'll have to have you on another episode just so we can further discuss this. So thank you, and we want to have you back.
Happy to be here, and I'm looking forward to that. Thank you.